Generative Geometric Construction in CLACL. The script builds nested squares from primitive instances, computes a reference distance from geometric intersections, and selectively connects points based on this threshold. The final structure emerges through logical and spatial verification rather than arbitrary drawing. Step 1. Include the basic definitions for the square. Step 2. Definition of model I. I indicates that the model manages an array of instances. Step 3. Primitive instance A and primitive instance B. Step 4. Creation of a distance relationship, radius, between B and a point x1. Step 5. Creation of the ternary between relation. Step 6. Call to the Fig square model defined in the included file. Generates a square with vertices !B, !A, !C, and !D. Step 7. Translation operations to find midpoints or auxiliary points. Step 8. Intersection of the diagonals to find the exact geometric center, !sen. Step 9. Projection from the diagonals to find new internal or external vertices. Step 10. Generation of the second square based on the newly calculated points. Step 11. Definition of a grid of relations, construction lines. These connect the vertices of the inner square with the outer one. Step 12. Computation of the intersection, int z, between two specific relations. Assignment of the result to the $int_z array. Step 13. Computation of the distance, gap, between a vertex and the found intersection point. This distance will become our golden rule for the next filtering step. Step 14. Definition of additional intersection relations, complex grid. Step 15. Cleanup, removal of construction instances not visible in the final result. Step 16. Global graphic settings. Step 17. The core of the generative engine. Iterates over all distinct pairs $A, $B generated by model I. Logical verification block. Step 18. Compute the distance between the current pair. Validity condition. The pair is valid only if its distance is less than the previously computed distance. If false, the system discards this combination, local backtracking. Step 19. If the test is passed, execute the following code. Step 20. Draw the connection between points that passed the filter.